Hi Algebra 2 students, it's Mrs. Delka, and we're going to talk about the evolution of numbers. So I'm using Math is Fun as a website for a resource, and I'm going to include the link into the Canvas. This is starting for week September 28th through October 2nd, I believe. So let's kind of talk about that. So what is the simplest idea of a number? It's something to count with. So we do have counting numbers such as 1, 2, 3, 4. And, we use numbers all throughout the years. We have, you have 3 friends, a field can have 6 cows, so forth and so on. Then there's this new concept called zero that was introduced. And it's natural to us now, but it wasn't always natural to early humans. So we can count dogs in this picture, for an example, but you can't count nothing. There's nothing there on that grassy knoll except for grass. So, then we talk about placeholders, and about 3,000 years ago, people needed to tell the difference between numbers like 4 and 40. Without the number 0, those two numbers look the same, so we use 0 sometimes as a placeholder, and that's where place value comes in. And then we're going to discuss just the word number. There's an idea of 0 that began, but it wasn't for another 1,000 years that people started to think of it as an actual number. So the example given is like, I had 3 oranges, then I ate 3 oranges, so now I have 0. And again, these are things that you've probably heard of before, but we need to discuss them, and I want you to have the history behind numbers to start Algebra 2 out the correct way. So for whole numbers, we're going to add 0 to counting numbers to make a new set, but we need a new name, and those are called whole numbers. So there's counting numbers that start with 1, 2, 3, 4, and then there's whole numbers where they begin at 0, and they can go 1 to 1,000 to 100,000, but it always starts with 0. That's a whole number. And then there are natural numbers, which that can mean counting numbers or whole numbers. So you can have 1, 2, 3, 4, or you can have 0, 1, 2, 3, 4, and so forth and so on. I'm sorry about the background noise too. I'm like having to do this outside in a hallway by bathrooms. So then we go into negative numbers, which you guys are familiar with. And so looking at this number line right here, 0 is your midpoint, and whole numbers go forward, but then negative numbers go backwards. We're going to get more into that in just a minute, but we definitely need negative numbers, one of them even being that, we need them for temperature. And so they give us an example of, yes, it may be 0 degrees Celsius, which us as Americans, we don't use Celsius, we use Fahrenheit. But if you talk about being below 0, you're talking about negative 20 degrees Celsius. Negative cows. And in theory, when we have a negative cow, think about this. If you just sold 2 bulls but can only find 1 to hand over to the new owner, you actually have minus 1 bull. So now you're in debt. Makes sense. So negative numbers exist, so we're going to need those for new sets of numbers to include them. And then there's something called integers. We have a new set of numbers that are called integers, and those can be -3, -2. The dots, the ellipses, mean that they can go on infinitely. Integers, though, they include 0. So you can't have a -0, that would be a negative number, but you can have 0 in your integer list. Then we have fractions. So they give us a picture of an orange, and they want you to share it with someone, so you cut it in half. You've just invented a new type of number. You took 1, you divided it by 2, and you came up with 1/2, or if you're better with decimals, it would be 0.5. The same things happen when we have 4 biscuits and want to share them with 3 people. They get 4 out of 3 biscuits each, a new type of number and a new name. And then we have rational numbers. This is a number that's written as a fraction. So if P and Q are integers, 3 and 2, then 3 with a slash 2, which would be a fraction, is actually, when you divide that on a calculator, you get 1.5. This is where rational numbers come in. This is where they have fractions and decimals involved. The only time this doesn't work is when Q, the bottom part of a fraction, is 0, because you can't divide by 0. So that number then becomes undefined. So then half is a rational number. 2 is a rational number also, because we could write it as 2 over 1. Which that's just another way to write 2, but as fraction form, any number over 1 is that number. So here's an important thing. So rational numbers include all integers and all fractions. And also any number like this one, 13.31689880325 is also rational. And it seems to include all possible numbers. Now there's more. So I'm going to stop actually, and we're not going to continue on too much. What I want you to do though for your very first assignment this Monday is we're going to make rational and irrational number charts. So in class or at home, it doesn't matter, I want you to really focus on this chart right here because you're going to need it for the whole school year. This isn't note-taking, so as far as your accommodations go, your accommodations are being met. But so I'm going to save this image, and we're going to call them real numbers. And later on today, I will upload it for the Canvas for next week. But I want you to write these things down to help you. And you can see lots of square roots over here, and that's because irrational numbers fall over there when they don't become whole after they're square rooted. But I want you to make a chart similar to this, and like I said, you're going to utilize it over these next few weeks. And I need you to get familiar with these words, okay? So this is your vocabulary lesson, and you have an assignment where you're going to draw, color even if you want it to make it look nice, what you see when I provide it in Canvas, and then you're going to upload that picture of it onto Canvas, and that's going to be your assignment. All right, guys, thanks for watching, and I appreciate you, and I'll talk to you on Tuesday. All right, bye.